Okay, let's talk about geometric sequences. Geometric sequences are patterns that have common ratios, while arithmetic sequences are patterns with common differences. And the difference is, if you subtract to find the common difference for an arithmetic sequence, what do you think you do to find a common ratio? Well, it's going to be division. So if you look at the examples, what are the common ratios for these geometric sequences? Well, what are we doing here? We're multiplying by 3 each time. Or you can say, look, 27 divided by 9 is 3. 9 divided by 3 is 3. Therefore, my common ratio is going to be, either way, 3. When you look at the next one, it might not be so easy when you say, well, 27 times what equals 9? Sometimes it's easier to say 9 divided by what is 27. Either way, this can be confusing, but you can solve 9 divided by 27 because it looks like this. So R equals 1/3. Be sure that if you need to, pause the video. So how can you tell if a sequence then is geometric or arithmetic? Well, it's really quite simple. It all depends on whether it's added or subtracted, or multiplied or divided. If it's added or subtracted, then you know it's arithmetic. If it's multiplied or divided, you know it's geometric. Now let's look at some of these recursive sequences here, or geometric sequences. We know that recursive formulas repeat. Therefore, if we know our first term is 3 and our common ratio is 4, just like with an arithmetic sequence, we can see a recurring pattern. We have our first term is 3. We multiply by 4 to get the second term. It's 12. Then we multiply that term, 12, times 4 to get this term. Then we multiply that term times 4 to get the next term, and so on and so on. So it turns out that we take the value of the previous term, we multiply it by our common ratio, and that's how we get the next term. So when we write it as a general formula, that's where we come up with T sub n equals T sub n minus 1 times R. If we look at the explicit formula, it's very similar except for one thing. We start with our first term, and we're going to multiply the first term times, instead of 4, we multiply by 4 to the first power. This helps us find a specific term instead of needing always the previous term. So if we're looking for the third term, we're going to multiply 3 times 4 to the second power. If we're looking for the fourth term, it's the third power. The fifth term, it's the fourth power, and so on. So then our generalized formula becomes T sub n equals the first term times R, the common ratio, to whatever n is, minus 1 to get that previous exponent, or that previous term. Okay, now let's look at them. We mostly use the explicit formula. There's one for if we know the first term, and then there's one for if we know a different term, which we will call x. Here we have, let's say we want to find the fifth term, so that means we're going to find T sub 5. And we know the first term is going to be 3, and the common ratio is 2. All we have to do is plug everything in. We're looking for T sub 5, n is 5. Therefore, we have n minus 1, or 5 minus 1. So we end up with our common ratio is 2 to the fourth power. We're looking for the fifth term. It's going to be the fourth power. So 2 to the fourth power is 16, times 3 is 48. Now we look over here. Let's say we don't know the first term. We're going to still find the fifth term, but we know that the eighth term is 128, and the common ratio is still 2. So we have to plug in, again, what we know. We know that if we're looking for T sub 5, then our n is going to be 5. We know that if we're looking for T sub 8, then we know that our x is going to be 8. So all we have to do is plug those in. Then it becomes very simple. We have t to the negative, or n, I'm sorry, I'm getting my letters all confused. T sub 5 equals, our eighth term is 128. So it's going to be 128 times t, or 2 to the negative 3, because 5 minus 8 is negative 3, and that is perfectly acceptable to have that. It just turns it into a fraction. So now I have 128 times 1/8, which is 128 divided by 8, and I end up with 16. Another one. Be sure to pause and try these yourself before you go on to see how you do. Let's find the recursive and explicit formula for a geometric sequence whose first term is -5 and whose common ratio is 2. Well, here we are not looking for anything specific, so this is going to be a general formula. So we have T sub n equals T sub n minus 1 times r. What's our common ratio of r? It is 2. We can also write it like this. It looks a little bit cleaner this way, but either one of these is correct as long as you make sure you have that little multiplying sign there. Now let's look at the explicit formula. We still have our T sub n, not looking for anything specific. Do we know our first term? Yes, it's -5 plus, oops, that should not be a plus, times r to the n minus 1. So if this is the case, if our first term is -5, we plug that in. Our common ratio is 2 to the n minus 1. Do we know what n is? No, we don't. So we're going to have to leave that as n minus 1. Can I multiply -5 times 2 here? No, I cannot, because according to the order of operations, we must do exponents first. So my final answer is T sub n equals -5 times 2 to the n minus 1. That is the explicit formula. Let's try a few. Find the fifth term of the sequence defined by the recursive formula that's given right here, and our first term being 8. Okay, easy enough. We know what our formula is. It says the fifth term. We're looking for T sub 5 equals T sub 1, our first term, it's going to be 8. Our r, what are we going to do for our r? Well, we look at our recurring formula here. Recursive says that it's going to be 3 times the previous term, so I'm going to multiply by 3. R equals 3. So it's going to be 8 times 3 to the n minus 1. We've got 5 minus 1, 3 to the 5 minus 1. So I have 8 times 3 to the 4th. 3 to the 4th happens to be 81. Whoops. 8 times 81. Oh my goodness. I do not know what 8 times 81 is. Let me quick find it here. 8 times 81. 648. So, T sub 5 equals 648. There we go. Let's try another one. This one is a little bit more complicated because it looks like we've got fractions, but we want an explicit form of the geometric sequence where the first two terms are 2 and -2/5, and our fifth, we want the first 5 terms of that sequence. So we need two things here. We need an explicit form, and we need the first 5 terms. Well, our explicit form is going to be, here it is right up here. It says the first 5 terms, but we just need the form. So we're going to do T sub n equals our first terms, 2, times r. We need to find r. So we've got fractions here. So I'm going to end up with -2/5 times 1/2. So my r is -1/5. So if that's the case, then it's going to be -1/5 to the n minus 1, the first part of our answer. The second part is the first 5 terms. Well, lucky for us, we've already got 2 and -2/5. I just need 3, 4, and 5. Well, I know that I just need -2/5 times -1/5, and I'm going to end up with positive 2 over 5 times 5 is 25. My next term then is going to be 2 over 25 times -1/5, and that's going to end up giving me -2 over 25 times 5 is 125. Now for my last term, I have -2 over 125 times -1/5, and I end up with 2 over 625. 1, 2, 3, 4, 5 terms. We are done. So, what if we need to find 3 geometric means between 6 and 96? Well, how many common ratios do we need? 1, 2, 3, 4. Now remember, in this case, we are not multiplying or we're not adding. We're not going to say we've got, 4 r's, so we're not going to add 4 r's. And we can't multiply 4 r's either, because we're not doing 4 r's. We're doing r multiplied 4 times. So that's going to give us an exponent. Therefore, we have 6 times r to the 4th, which is going to get us to 96. So what's the first thing we have to do then is we're going to have to take 96 and divide that by 6. 96 divided by 6 is 16. So then we have r to the 4th equals 16. So can we take the 4th root of r? Yes, there are 4 numbers that multiplied together will give us 16, and that number happens to be 2. So in this case, r equals 2. That means it says find the 3 geometric means, so now we have to do that. 6 times 2 is 12, times 2 is 24, times 2 is 48, times 2 is 96. Done. Now let's say we have the 4th and 9th terms of a geometric sequence, and we need to find the explicit form of the sequence. Well, that's easy because we have this information right here, and it says find the explicit form. So all we have to do, always make sure that you are finding what they ask. So if we've got 4th and 9th, what do we need to do to find the explicit form? We are going to have t sub n equals t sub 1 times r to the n minus 1, or we can use this formula right up here. It's not all that hard. But what we are going to need is an r. So what we just learned before is we've got the 4th term, so we know that t sub 4 is 20, and then we've got 4, 5, 6, 7, 8, whoops, I'm going to run out of room. T sub 9 is negative 640. So the first thing I'm going to do is there's 1, 2, 3, 4, 5. So I have r to the 5th. 20 times r to the 5th equals negative 640. Divide negative 640 by 20, and I get r to the 5th equals negative 32. Again, r equals 2. Now we can take the 5th root of this negative simply because we have an odd exponent, so that works. We won't end up with the square root of a negative. So this is hallelujah, hooray. So now what we have to do is we have to plug it in appropriately. We have t sub n equals, do we know our first term? No. So we are going to use the t sub x in this case. And we will write it like that, times r, which is 2 to the n minus x. That is the explicit form they're looking for. They did not tell us to find the 5th term or the 25th term or anything like that. We could, however, do this. T sub n, well, we don't know which term we're looking for, but we can take, let's say, the 4th term and say we're going to find t sub 4 times 2 to the n minus 4 if we want to go there, but you really don't have to. Just leave it right here, because this really doesn't help all of that much. So just leave it right here, and that is fine. Okay, we are about to run out of time, so I will go ahead and say pause and try this one on your own, and then I will write the answer down right before we run out of time. Okay, so if you did the work correctly, you're going to end up with t sub 6 equals 160. 2 to the 5th equals 32, times 5 is 160. There we go. We are out of time. See you in class.